Hello everyone, I'm Dadila Hanifi. I'm doing master degree in Coming University of Science and Technology. Today I'm going to defense my currently experiment and my subject topic. My subject topic is for master degree adopt metals to improve mechanical properties of 8040 ceramic plasma ceramic coating. Today I'm going to talk about my topics. My topics is now effect of nickel aluminum doping on the cracks and mechanical properties of 8040 plasma spray ceramic coating. My supervisor name is Sampan. Contents: the purpose of significant of research project, the experimental statements and methods, current experimental progress and next plan. Part 1. The purpose and significance of research project. Whereas one of the three main forms of the material failure has been attracting much the attention. Thermal spray plasma. Thermal spraying technology is one important technology for surface reinforcement and protection of material and equipment, and important position surface technology. They use thermal spraying technology to prepare wear resistance coating to prevent the failure of the mechanical equipment compounds and improve their life, has been widely used. The 8040 coating exhibit the excellent combination properties, which is including high density, high ductility, wear resistance, corrosion resistance, and relatively good fatigue resistance. 8040 coating widely used to protect metals industry. Ceramic coating has been a great potential to mechanical and methodical fails. Main question in here: 8040 ceramic has a low fracture toughness, which is directly related to the failure. The ductility and toughness of ceramic material are very poor. Lower toughness and lead to breakage between the coating and substrate, which accelerated the formation of the cracks, and therefore the cracks could result in the failure of the coating. Nickel aluminum based alloy purpose for doping. Nickel aluminum based alloy are attractive material for high temperature structural application too. They are excellent properties such as high melting temperature, high specific strength, good oxidation, wear resistance. Nickel aluminum based alloy coating was used for better corrosion and protection and wear resistance for metals, and enhance the toughness of ceramic coating. Recent research have shown nickel aluminum plus alumina composite is applicable for high temperature application too. Also, good oxidation properties and excellent creep resistance are good advantages of this composite. So it is good option for coating purpose. Part 2. Experimental such as methods. Our experimental methods, we doped 8040 plus metals after mesh analyzing, doping and drying, spray by APS, then XRD, then taking picture by ECM, then do Becker hotness, then taking image APMA, then analyzing or doing 3-point bending test ACM, and finally we're doing wear resistance test. It's a form of my experiment. The done substrate and nickel aluminum as used as a bond coat, and 8040 plus nickel aluminum we use bond coat, top coat. It's a composition of powder, distribution of aluminum 8040 plus nickel aluminum powder. In here is 8040 pure 8040. In here we use nickel aluminum base alloy, and this 8040 powder. We taking picture ACM after doping. And then here is also macro size of composition of our powder. Then part 3, experimental strangeness and methods. We want to show for cross-sectional microstructure 8040 plus nickel aluminum without nickel. In here we got ACM picture from ceramic coating substrate, bond coat and top coat is without nickel aluminum. On here so we done doping nickel aluminum 5%, in here 10%, when in here 20%. We directly have seen white rich one is nickel aluminum rich one, and dark areas ceramic rich one. We done ADX line for distribution of element surface 8040 plus 20% nickel aluminum based alloy plasma spray ceramic coating. We done XRD from surface. We check the element composition and surface of our samples 0%, 5%, and 10%, and 20%. We have alumina, titanium, nickel, alumina, and alumina, nickel, aluminum, titanium, or like this. We also got the APMA picture from cross section. We want to know about distribution of our material, special elements, nickel, aluminum on 8040 ceramic materials. ACM watch for cross section 8040 plus 20% base alloy and APMA mapping of the cross section of the coating. We have seen in here nickel, aluminum, titanium, oxide, and iron. In here we got the ACM cross-sectional image from 8040 with 20% nickel aluminum doping. We compare two picture. This one and this one picture is without nickel aluminum, only pure 8040, and this one with this one 20% of nickel aluminum doping. In here also we compare two ACM pictures, one of the 8040 with 20% nickel aluminum, one is without nickel aluminum, pure 8040. In here we can have seen clearly is in this picture the same size, too much cracks, too much porosity, and in here no too much cracks and no too much porosity. This is one of a good result we got from our experiment. Also, we done wear resistant hands. Duration of wear test, we compare the weight of four samples, one of 0% nickel aluminum, 5%, and 10%, 20%. Duration wear, we find it 0% in this many 8040 without nickel aluminum is lost too much weights than 8040 doping 20% nickel aluminum. We can see in here a failure zone of morphology and crack growth in beds under the apparatus stress on the top coating. We then after Vickers hardness test, we got this ACM picture from cross section. We can see the cracks grow to directly going to the ceramic area. Then we change the way going to the interface. It's mean nickel aluminum doping has a good effect to our 8040 ceramic plasma ceramic coating because it's resistance of opposite of cracks. This ACM we got from picture from after Vickers hardness test. We start from substrate and interface between substrate and bond coating, then going bond coating and interface between bond coating and top coating. After got the result, we found it by doping more and more nickel aluminum in 80-40 ceramic coating, fracture toughness grow increasing and hardness decrease. We can see clearly in here by doping 20% nickel aluminum, cracks in here, breaker hardness, especially hardness, come down and increasing. Also, we can see in here result of breaker hardness. We can find it by 20% doping hardness of ceramic coating decrease. The other, we done 3-point bending test. After 3-point bending test, we find it by doping 20% nickel aluminum in 80-40 ceramic coating, fracture toughness increase, and we can see directly result in here. 20% nickel aluminum doping in here, we can see clearly fracture toughness also increase. We also analyzing this result by theoretical, by equation. The fracture toughness also energy release of ceramic coating were calculated using equation 14 and 16 that researched by Chowley. After analyzing, we calculated by equation, we find it fracture toughness of 20% doping nickel aluminum in 80-40 is increasing 10.5. Then 4 to 3 is 0%. It means 80-40 without nickel aluminum is fracture toughness is not good. And in here also we analyze energy releases 0%. It means 80-40 without nickel aluminum is release too much energy, but 80-40 with 20% nickel aluminum release small energy. A small energy, releasing the small energy related to make small cracks. It means no too much cracks in the surface. Also, I've seen in wear test. After wear test, we got this is in picture. In here, within 80-40 with non-nickel aluminum base alloy is too much cracks. But in here, also 80-40 with 20% no too much cracks, and we have seen the composition of nickel aluminum, the white area and dark areas 80-40. We also done ADX line from surface 80-40 with 20% after wear resistance. We want to know the composition of your element distribution in the surface. We got ADS spot 1, ADS spot 2, ADS spot select area 1 and select area 2. We have seen nickel alpha phase, also titanium alpha phase, beta phase. We have seen in nickel aluminum, also nickel element distribution, aluminum distribution, or titanium distribution in the surface after we have test we done ADX line. Next plan, analyze the current experiment result and complete the completion of my papers, and organize the second my experiment effect of CU doping on cracks and mechanical properties of 80-40 plasma express ceramic coating if we find chance to go back to China. The finally steps analyzing the second experiment and result and starting my writing thesis. In the conclusion, we are founded by doping 20% nickel aluminum in 80-40, fracture toughness increase and hardness decrease. Duration of we found it with compare 80-40 without nickel aluminum doping and 80-40 with 20% nickel aluminum doping. In 80-40 without nickel aluminum doping has too much cracks and it means it's cracks make it directly to breadthness of the coating. And 80-40 with 20%, not too much cracks. Because of this is a good result, we can more study and doing research about the safety. And we done wear resistant test. After wear, we done weighs all the samples. After done wear resistance test, we weighted to all samples and can compare 80-40 with non-nickel aluminum doping. This means loss 0%, 0.25% grams more than the 80-40 with the 20% nickel aluminum doping. This means 80-40 with doping is nickel aluminum to enhance the wear resistance and wear properties. Thank you so much.